The first segment of this is a focus on the evolution and development of a little transceiver that I call the choking hazard. It's a postage stamp sized 2.7 gram Pixie transceiver. And I want to give you a little bit of history on this and kind of a little background on my story as a ham radio operator and how I arrived at this fun little project. So as Hayden mentioned, my name is Adam. My amateur radio call sign is K6ARK, and I'm a mechanical engineer by degree, but I don't get much of a creative outlet in my work anymore, so I use amateur radio as kind of my main outlet for that. YouTube is another great outlet for my creative side. I really enjoy making videos. Some might call me a social media influencer, but I like to just refer to myself as a geek with a camera that likes to film my adventures in ham radio, playing around in the mountains in hopes of encouraging others to explore, tinker, build, and just have fun with the hobby. As another branch of the hobby, I recently started selling some antenna kits. The second part of my presentation talks a little bit about some of the antennas and matching units that I've developed and started selling. And my goal with those was really to develop a compact, portable, effective antenna option for other hams to build as a fun kit project and support their adventures in the outdoors. And then finally, in my spare time, I also work as a search and rescue volunteer with the San Diego Mountain Rescue Team. And it was actually the search and rescue team that originally got me started in ham radio. I had a friend on the team that was earning his ham radio license. And I thought, well, I'd really love to learn more about these radios we use on the team. And getting my amateur radio license was a good way to do that. So after a bit of studying and testing with a local group here in Southern California, I became KJ6HOT. And no, that wasn't a vanity call. That was what the FCC decided to give me on the first go around. So I stayed a tech for a few years, operating on 2-meter repeaters around town during my commute to and from work. And eventually I picked up a 10-meter transceiver, a Radio Shack HTX10. And I never really thought I'd get into HF a whole lot. I was having enough fun and enjoyment out of just operating on 2 meters, but that 10-meter rig kind of changed things for me. I built a simple wire dipole, set it up on the deck of my apartment in the city, and started tuning around, trying to figure out how to use the thing, and didn't really hear much. The band just really wasn't open for me. And then one evening, I was tuning around and I heard what sounded like a chipmunk calling CQ on 28.400. And I replied with my call sign, and the nice guy on the other end, N9NUQ, the QSL card he sent me there is on the screen. He was kind enough to let me know I was a little off frequency and coached me over the air through how to use the fine tuning knob on that little Radio Shack radio to zero beat him and complete the contact. So it was a really positive experience, and it drew me more into the HF side of things. It was just really cool to be able to make that contact halfway across the country. So I studied up and earned my general class license in 2013. I bought a used Yaesu FT817, and living in an apartment with a little QRP HF rig, I didn't have a whole lot of, and I put together this nice little super compact and ultralight kit consisting of the FT817, some coax, a lithium battery, a dipole antenna, and all in a little plastic case. The thing weighed, 5 or 6 pounds, and I thought that was the best thing since sliced bread, this tiny little portable kit. Little did I know. So I started doing some SOTA activations, heading up to mountaintops and playing radio from there, making contacts, learning more about HF operation. And I saw some opportunities to make the kit smaller. This FX4 transceiver came out, which was about, maybe a third of the size of the FT817. So I picked up one of those. And even though I didn't know anything really about how to operate Morse code and didn't really have much interest in learning at the time, I purchased a Rockmite kit and assembled a little Rockmite transceiver and placed it into a small Altoids tin. And it was really years before I ever made a contact on that thing because I wasn't proficient enough with Morse code. But in that kit, I kind of started getting into hacking things together and making kits smaller. And I built in a, looks like my video's dropping here. And I built in a battery, a USB charge port, and let's see, yeah, so the battery, the USB charge port, the on-off switch, everything was kind of self-contained in that that little mint tin. So that was kind of my first steps into downsizing things. So a few years later, I found myself on a SOTA summit with a friend, another guy from Southern California here, Tim, K6TW, and with no cell reception, I wasn't able to self-spot for the summit activation. I was trying to operate sideband, and I really struggled to make those 4 contacts that I needed. Tim, on the other hand, with his little Mountain Topper MTR3B, was just tapping away. He was automatically spotted through this reverse beacon network thing that he told me about. And within just a few minutes, he had the necessary 4 contacts and then some to complete the activation. And that was and learn Morse code so I can become a CW operator. So by around 2018, I became proficient enough at Morse code to start activating SOTA summits with CW rigs, and I brought that same little mint tin Rockmite rig out to a summit, and its massive 300 milliwatts reached its way to stations all over the western parts of the United States, and made probably 15 or 20 contacts just from that summit alone. And although the performance of that rig left a lot to be desired, it was a really good way to kind of just build that skill and learn to use Morse code a bit more. Eventually, I picked up a Mountain Topper and some other smaller CW rigs that helped in that. But I always kind of had this affinity for these little mint tin radios and these little radios in these real small packages. So I started building some other kits, including 49er, which is the rig on the upper left, another version of the Rockmite on the top right and bottom left, and the venerable Pixie rig that we all love to hate. It's a really nifty little rig with a very simple circuit and minimal components, and as you guys probably know, pretty terrible performance. But the beauty of the thing is in its simplicity. And, you know, I've been kind of an outdoorsman, a backpacker, and a minimalist in a lot of things that I do my whole life. So there was something about this Pixie that was kind of the equivalent of that ultralight venture that really just drew me to it. And I thought, I'll bet I could make this smaller. I started taking a look more closely at the circuit board and seeing where I could remove parts of that PCB to make it smaller. And eventually I figured, you know, I could fit this into this kind of mid-sized mint tin, the one at the top there. And after doing that, I said, you know, I'll bet I could actually fit this thing into an Altoids Smalls tin, which is about a third of the size of your standard Altoids tin. Because, you know, obviously a full-size Altoids tin is just way too big for a transceiver. So the result was that little rig you see on the bottom right. It's a sub 2 ounce station, and I integrated a battery into there with a charge port. And that little contact switch that you see on kind of the top portion of the board there, that white contact switch with the chrome switch lever on it, is actually not the Morse code key. It's the switch to turn the rig on and off. And I positioned it such that when you close the lid of the transceiver, it turns the transceiver off, and when you open the lid, it turns it on. And the straight key for the rig is actually that copper wire that when you press on it, it actually grounds out to the case of the crystal there, and it works quite well. So clearly, a sub 2 ounce, or what is that, roughly 55 gram radio in an Altoid small SIN, clearly that's still too big. So what can we do to make this thing smaller? I started working with some friends here, other SOTA activators in California, Rex KE6MT and Jeff AA6XA, to start to create a surface mount version of the Pixie. And Jeff did some design work first, made kind of the first efforts of it, and those are some of the ones you see in the middle there, the square shaped purple Osh Park board, and purchased some parts and sent them out to us to assemble, and they didn't quite work. We had some issues with both the circuit design and the components we selected. So the project kind of fell by the wayside for a while. And eventually I said, you know, I just need to learn how to design PCB and how to do this myself. So I downloaded Autodesk Eagle and started learning kind of just the hard way through trial and error how to design the schematic, choose parts, and lay out the board. And on about the third attempt, I sorted out the kinks and actually had a working board. And realizing I had a working unit, and had them get on the air to see if they could hear me. And sure enough, called CQ a few times and got Rex in a log coming back. And I figured, what the heck, I might as well call CQ a few more times. And I had a random station come back, a gentleman up in the central part of the state, about 400 miles away. And he replied giving me a 579 report, and we subsequently rag-chewed using that silly little radio for about 10 minutes. I was blown away. I couldn't believe the thing actually worked. In the, well, I should say in the previous slide, you could see the rig next to a couple of Anderson power poles. So that gives you an idea of the size, roughly, maybe 20 millimeters long by about 12 millimeters wide, and maybe 5 or 6 millimeters high. And if you know the size of the average crystal, well, you can see the crystal outline on one side of the board there on the right. The small passive components here are 0402 size components, so that kind of gives you an idea of just how ridiculously small this thing is. So this is a screen capture from a YouTube video. We'll go ahead and move on to the next one here, and let's play a short clip of the one on the next slide there. That'll give you a little bit of an example of the operation here. And what you'll see attached to that is actually a tiny end-fed half-wave matching unit with an FT20-43 toroid, and again, that wire straight key attached to the board there. So go ahead. So as you can see and hear there, the Pixie has no side tone, so all you hear is that thump of the LM386 audio amplifier turning on and off as you key the transceiver. So the rig ends up putting out about 800 milliwatts with a 3S lithium ion power supply, 11 and a half or 12 volts there. And it actually works okay. It's possible to make contacts with it. On this SOTA activation, in this video, which you can find on my YouTube channel there, I made, I think, about 15 or 20 contacts with the rig before calling it a day and moving on, and it was just a blast. As far as future work on this little rig, I intend to have some of these manufactured at some point and sell them for a very modest and reasonable rate. The one thing I want to work out still on them is to better suppress the harmonics. It doesn't quite meet the legal requirements, as do, I think, all of the Pixie transceivers with just a very simple low-pass filter. So I plan to add a couple of elements to that to make it technically legal, and get it to perform hopefully a little bit better. So that's the choking hazard, or micro Pixie transceiver, as I like to refer to it. One of kind of the fun little minimalist projects that I've come up with as a ham radio operator. And in the next slides, I'm going to talk a little bit about another project, the antenna side of things, and it's the miniature micro transformer kits that I sell at this point. And quite a few operators are starting to use these here in the US, and I know there are a few in Australia as well. So when I picked up that original FT817, I was looking for kind of the ideal mini antenna to go with it. And the best thing I could find was this PAR NFED's trail-friendly antenna. It's an NFED half-wave with this cute little matching unit box made for QRP power levels. And the thing worked quite well. It's resonant on 40, 20, and 10 meters. And when I bought this thing, I bought it thinking there's no way I could ever build something that's as good of an antenna as this and as small and compact as this. Fast forward a few years, and I was tinkering around with some parts in the shop, and I had some solder BNC connectors for coax attachment and some FT50 size toroids. And I set one of the toroids on top of one of those BNC connectors, and I thought, hey, that's actually a really good fit. So I took out the Dremel tool and did a little grinding and attached a shunt capacitor that you can see down in that bottom right, across from the center pin to ground. I figured out how to wind a 49-to-1 onto that toroid and get it all soldered into place. And then figured out how to route the antenna wire stub out of it and connect a wire. And I made a video about this. I shared it with others, and it was a very effective antenna, but it was pretty difficult to build. So a friend of mine, Matt, N7MCB, sent me a message one day and said, hey, have you ever thought about using a PCB mount BNC connector and building a PCB to make this build and this design easier? And I said, that's a great idea. So sure enough, that's what I did. And I came up with this miniature PCB that's maybe 12 millimeters or so in diameter there, and attaches to the surface, this BNC mount, PCB mount BNC connector, and just really ends up making the whole build much easier. That kind of came to the point where I said, well, I should turn these into kits and start selling these so people have access to this and can easily build their own. So I sell these now on Amazon in the United States here, and they are, I think, potentially available overseas in some places, although I know there's some challenges with that through Amazon. And I'm working on getting distribution further, but it's hard to keep up with sales even just here in the States. So so perhaps at some point I'll be able to get more availability down there in the southern hemisphere for you guys. On the bottom right there is a typical kit that I now bring into the backcountry on these ultralight SOTA expeditions. It's a mountaintop MTR2B lithium-ion rechargeable battery pack there, that's in the 9-volt form factor, a tiny version of my antenna kit built onto an RCA connector, and the whole station there weighs in capacitive touch paddle separate key. So through all of that, I made my way from this big, heavy 5 to 6 pound FT817 and figured out how to distill all of this down to really a tiny kit, even to the point where it's, a few grams for that micro Pixie or choking hazard transceiver, which is usable, but obviously not the performance that you get out of a rig like this. So with all of that, I just encourage you all to experiment and learn and have fun with building. Not every kit needs to be super small or super ultra light. And if you've perused my YouTube channel there, you'll see a few other builds. And I'd like to show you some of those briefly here to kind of get your interest going on checking some of those out. 10-meter 4-element wire Yagi that I built and carried up to a SOTA summit here to play in one of the 10-meter contests. Those are 4 17-foot telescopic poles, and spread between them are straight wire elements, 4 of them, a driven and 2 directors and 1 reflector. For a 4-element Yagi that has a boom length of, let's see, probably almost 10 meters there. It's a pretty long boom length. So there's a video there on my YouTube channel to check that out. Another thing that I've wanted to do is to make some real long distance 6-meter contacts. And to do that, I wanted a Yagi that, I should say 6-meter Yagi, not 5 meters. It's a 5-element 6-meter Yagi that folds down with that aluminum boom elements with a portable rotator that I use with that sometimes. You'll find that on. And the last slide there is an antenna that I call the double bobtail. You guys may have heard of the bobtail antenna. And I found through some antenna modeling that if you add a passive second bobtail element at the right, or bobtail antenna at the right position behind it as a reflector, you get a more directional antenna with quite a bit more gain. And with just 4, lightweight telescopic poles, you can get a really high performing antenna. This is a 15-meter build that I did, and I was actually able to make a contact with Hayden well before the peak of the solar cycle here with a relatively modest station on his end and just 100 watts from a SOTA summit on my end. So check those out on my YouTube channel. I think you will enjoy seeing some of those builds.
I just wanted to say, Adam, I've got a question, and it's a bit of a loaded one. You know where I'm going with it. What's your craziest antenna that you've built, if you know what I mean?
Well, the craziest one is, for what it's worth, I can't start my video here. It's still blocked. But so the craziest antenna that I've built, and perhaps you can search for it and bring it up there, is an antenna that I built out of a stack of about 40 beer cans, aluminum beer cans. And yes, it took a lot of work to prepare the material to build that antenna. And I was able to weld those together with a MIG welder, wire the cans together into a 20-meter vertical antenna that I set up in the front yard and proceeded to make a whole bunch of contacts with, and it was a blast. Yes, the DX Brewmander, that's the one.
Yeah, this is the video of you welding and putting it together. So very impressive. And what did they say to you on air when you told them what it was?
Well, some folks made the obvious joke about a beverage antenna, which I thought was pretty good, and others were just a bit confused about it, and they're like, "You're using what?" But in the end, the darn thing actually worked pretty good.
What's the next project, Adam? You shrunk the Pixie. What's the next one?
Oh, there are never-ending projects, it seems. So one of the ones that's really a lofty goal, and I'm not sure how soon it's going to happen, but I'm planning to make a 2x2 stack of 2-meter Yagis to hopefully try to make an EME contact on 2 meters from a summit. So that's a pretty lofty goal, and I'm going to need a very capable station on the other end to make that happen. But I do think it's possible with a 2x2 stack, and I've got 175 watt 2-meter amplifier with a preamplifier on receive that I think will help me out a little bit on that as well. So yeah, that's one of the big ones right now. The other thing I want to do is rebuild that 10-meter Yagi to kind of optimize its performance a bit more. And I think probably end up making it a 5-element. The boom length is really long enough for that with the bars that I'm using, or the poles that I'm using. So I'd like to make that a 5-element 10-meter wire Yagi with a good bit of gain.
Yeah, I was just going to say, your 2-meter EME, I'll be interested to see that. HB9Q, I2 FAK, you should be able to do that with 6 elements, and your 170 watts, you'll do it no worries. Just watch your foreground ground gain, and you'll do it no worries. Be interested to see it.
Awesome, I appreciate that. Yeah, that's some fun stuff. Another project I've been working on is to design and come up with a very low cost and simple rotator that can be used for portable antennas, like generally smaller stuff, that you're going to be able to bring portable, but that still benefits from having a rotator. There are some very small 12-volt geared motors that can feed that well, and I've got some designs that I've built through 3D printing. 3D printing is another thing worth mentioning. I've developed a Morse code paddle that's 3D printed that is the size and has very similar functional characteristics to a Palm Pico paddle, if any of you are familiar with those. So it's a very small portable paddle that retracts into itself for storage. And my design is a bit simpler. It doesn't have as much adjustability, but the side benefit is that it's very simple and the parts are very cheap, and I can build and produce them, and have been selling them at this point through word of mouth for about $30 US shipped to the US. So it's a pretty cool little project that I've gotten a lot of positive feedback on as well.
I've got a little project for you, seeing as how you've gone so small, and that is to build the rig in the heel of the shoe, key it with the tap of the heel, and trigger it with the tap of the toes.
I love it. I think that's a great plan.
Don't say that, Rod, because he actually probably will do it now, won't you?